My name is Jan Harzan. I'm the Executive Director for MUFON. We are a scientific research organization that basically collects sighting reports from the public and then goes and investigates them. Our mission statement as an organization is the scientific study of UFOs for the benefit of humanity, and we have three primary goals. We investigate UFO reports, we promote research into the UFO subject, and we educate the public on our findings. MUFON is really more just left of center, where we try to take a scientific approach by collecting the data first off, and then reviewing the data, investigating the data, and making sure that what we're seeing is actually something that's truly an unknown. We have 3,000 members worldwide. Many scientists, physicists, Ph.D.s, metallurgists, biologists, all the way down to just the average citizen who really wants to get involved. Some of those have chosen to become field investigators, and they go through our field investigative training courses. They become part of the team in their state or country where they reside, and they actually get engaged in going out and meeting this phenomena head on. We receive about 500 to 1,000 reports per month from around the world. Field investigators will take the case, generally review it, try to come up with a hypothesis, checking star charts, and we'll go put an investigation in place to determine what exactly happened. We've recently formed a science review board, and that board is made up of scientists from around the United States and around the world to review some of our more significant cases and try to render an opinion on them. What we'd like to do is be more outbound, more outspoken in terms of the really true UFO cases. So MUFON is moving forward with this approach, and we'll be publishing papers in these different areas to allow the general public and even the scientific community to be able to be challenged by what we're finding. That's the strength of MUFON as an organization, is being really the truth seekers of the UFO field.
Good morning. Our first speaker, Marc D'Antonio, is the Mutual UFO Network's chief photo and video analyst and is CEO of FX Models, a model-making and special effects company specializing in digital and physical models and organic special effects in the film industry. FX Models has done work for all kinds of organizations within and outside of the U.S. government. Marc has appeared on a number of networks, including CNN, Discovery, Sci-Fi, History Channel, National Geographic, and Discovery Science channels, performing on camera and working as a UFO investigator, a scientific principal presenter, and a photo and video analyst. Marc has also put together a team of top U.S. scientists who are working together with UFOTOG, pioneer Douglas Trumbull, to create high-end autonomous flying vehicles and robotic ground units to search for evidence of extraterrestrial presence, potentially using crowdsourcing methodologies. Marc's degree is in astronomy, and he has spent decades capturing thousands of images of many kinds of sky phenomena using a diverse range of photographic gear, from small cameras to backyard telescopes and even large multi-million-dollar professional telescopes in large research observatories. Let me not waste any more time, but welcome to the stage, Marc D'Antonio.
Hey, welcome to the symposium. This is great. I wanted to start off by relaying a little story. It was 2 in the morning, and I woke up because I heard a noise. And it was over my head in the attic of my house. I apologize for my voice. It sounded like the pitter-patter of little feet. Bum, 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 bum. And I could hear when the ball of the foot of this two-legged person in my attic, I assumed it was one of my kids, would turn. And you could hear the grinding of stuff under the ball of its foot. And I thought, it's 2 in the morning. Why is one of my children in the attic? You got to climb a narrow stairway. There was an open loft where you could fall 10 feet to the floor. and I was worried. So I got up, mixture of anger and concern, and I went in and I flipped the lights on in their bedroom. They were both in their beds. So my next thing was to go to the phone and call the police. Now, I run my business out of my house. I do work for the Navy, and I have some sensitive stuff. The police know. They showed up within seconds. And they came running up the stairs and said, "What do you got?" And I told them, and they said, "Okay, let's check it out." They walked in the house. We all walked in the house, went right to the staircase to the attic, and we saw that the attic door was still in place. Not one of us thought to go in the attic and check it out. That's why I called them. So this is the problem that we have. We didn't get any actual, tangible evidence. It was all anecdotal information, which isn't evidence, that we received from cases. This is an example. This real event that I'm relaying happened. It really happened. We experienced it. We felt the footsteps. We could follow them across the floor, the sound. And we couldn't say otherwise. No one could ever tell us otherwise. However, that in itself doesn't make a tangible case. It's anecdotal information. Well, you thought there was something in the attic. Did you see anything? No. Why didn't you go in there? I don't know. None of us do. So anyway, we didn't go in the attic, and it started me on a crusade to get better data in ufology, something tangible. Maybe security cameras could have caught something. I don't know. But I installed them, you know. And to date, I haven't caught anything but really cool spider webs doing these neat things in front of the lights, you know. But the truth is, when we look at the data we get from ufology, it's usually a fuzzy picture or a video going, "It's there, I see it." And we're looking at the thing going like this and trying to follow it around. I have all kinds of products that can stabilize video and stuff. But the truth is, when you're in the trenches doing this investigation, you're looking for something that reached us from an interstellar location. And that has been my focus for the last couple of years, trying to figure out not only if they're here, but catching them in the act. And to do that, we've developed a system that I'm going to show you shortly that we think is going to do that for us. But I have to give you some background. Carl Sagan said that, quote, "The Earth is a pale blue dot." With my voice in its current state, that comes out pretty good, you know? But we are really just a speck in the universe. And no one would think, most people wouldn't think that they would find us. And that's why the UFO phenomenon is treated with such disdain in the media. You know, I should actually be wearing a tinfoil hat right now. You know, look at this, doesn't it look good? But I'm not a tinfoil hat guy. I'm a science guy. And I use science to determine whether we are actually being visited or whether there's life elsewhere. And the truth is, we ask the question, could someone find us? And, you know, we think it's happened before. We really do. But there's no tangible evidence. There's anecdotal information. Remember those two words, anecdotal information. You always hear the phrase anecdotal evidence. They're mutually exclusive. If it's anecdotal, it's not evidence. Okay? It's information that could be evidence if you sum it all together, multiple witnesses, whatever. But just like the incident in my house, it's good as anecdotal information, but not as evidence. For me, I would call it evidence because my ears were hearing something. But for you, it's just information for you. Nothing to grip onto. Watch this video of the alien in my attic. You know, you didn't get that. You can't get that. So The problem is there's no tangible evidence, but just like my case, there's plenty of circumstantial evidence. And I just want to use one particular case to point out what I'm talking about, because history is replete with evidence, circumstantial evidence, of potential alien visitation. And this, one case I'll use, is the case from the Kimberley region of Australia from 5,000 years ago. Who's heard of the Wandjina? The myth of the Wandjina. Okay, the Wandjina were up, right, see now you know. Oh, that, okay, I get it. The Wandjina were rumored to be a people that came from the sky, lived in the oceans, and had mastery over the water. Now, there's also mythology surrounding the Wandjina and their visit to Earth. They lived underwater. However, they would come on land and interact with the people. And when they interacted with people on land, the people referred to them as owls. Now, the mythology and the myth of the Wandjina state that 2 boys tortured an owl to death. And as you can see in the slide, the Aborigine tribes were decimated by a water attack, as they phrased it. Now, those who don't think that this could be extraterrestrial in origin, they'll say, well, maybe it was a tsunami and it just kind of got convoluted throughout history. That's possible. I can't say it's not true. Excuse me. However, I have to say, when you think about that phrase, the boys tortured an owl to death, I have to ask, was it really an owl? Okay. It could have been an alien creature. To me, that's possible. Now, because of evidence, circumstantial information and evidence like this, we have a good reason, a legitimate reason, to wonder if anyone's found us. And one thing that we can do is to try and find them. And that's just what we have done. Now, I have to qualify this. To find them means, because of our framework in our life, we look at it in terms of life like us. What's that mean? Earth-like, for instance. Life like us. Well, guess what? Here on Earth, we've found life not like us. All right? Down in the deep trenches of the Pacific Ocean, all right? They found these smoking chimneys. They're called sulfide chimneys. And they're spewing mineral-laden waters at 900 degrees. And that water forms the basis of an oasis that forms around those vents. We found new life forms at the ocean floor. This is the reason why we look for life on places like Europa, Jupiter's moon, or Enceladus, Saturn's moon. This is because these life forms that we found in the Pacific are existing in the most inhospitable place known on the planet. And when you think about life forms like this, I don't think that you would question for a second that they exist, because we see pictures, evidence of them. Now, the thing about the life forms on the ocean floor is that they are using chemosynthesis to survive. Most life on Earth uses photosynthesis, and these are chemosynthetic creatures. So we've found that to be really fascinating. And, excuse me, on some of the dives with the submersible Alvin, they found very interesting evidence that this chemosynthetic life is only temporary, because this place on the ocean floor is moving over the mantle of the Earth, where there's a hot spot. Excuse me. It's not vodka. Okay? And as it moves over the hot spot, that oasis we talked about goes away. And where the hot spot comes through again, this is the plates moving across the mantle that cause this. Another oasis forms. So on the ocean floor, you can see an oasis of life. And then farther away, in the direction the tectonic plate was coming from, you see the previous one and the previous one. It's leaving a long trail of dead sulfide chimneys. So we talk about life like us when we're looking for life elsewhere. It doesn't include these types of life forms, chemosynthetic life, microbial life we look for, but carbon-based microbial life, cyanobacteria, things like that. We don't have any idea whether they exist in our solar system, but on Mars, in November of, I think it was 2012, they noticed during the Martian summer a bloom of methane gas on the planet. Now, that wouldn't be so problematic for Earth because methane comes from volcanic eruptions, and we've got plenty of that going on. But Mars is tectonically dead. There's no volcanic activity at all. Not anymore. So where would this methane come from? The only place it could come from, the only other possible place, is that it was released from underground. How would that happen? It could happen if there were bacteria. And in the summer, they bloomed and grew. Methane is bacteria poop. Yeah, I know, it's true though. And so we could see that from the Earth with the sensors. Now, we need to find life as we know it, but what does that mean for us? Notwithstanding Mars, okay, life for us means a habitable zone exists around the star, and the planet sits in there. We'll discuss that. It also means liquid water can form on the planet, and the star system has to be stable. We've found a lot of those out there, by the way. Now, the habitable zones that place around the star, they're not too hot, not too cold. You've heard the term Goldilocks zone, right? Well, that's it. It's the Goldilocks zone around stars where a planet can form. Now, the planet would have to have an atmosphere, and for life like us, an atmosphere like us. We don't know if that's true. We don't know if it has an atmosphere like that, or these planets have atmospheres like that, because we can't really see atmospheres yet. We're working on it. Liquid water, it's okay to have liquid water. You can actually see on Mars remnants of where there was liquid water. And there's a lot of water ice on Mars, lots of it. And sometimes that water ice is released in a very quick burst of water when it's under pressure. And it shows up as a gully on Mars that's temporary, and the water's gone in no time. So when I say liquid water, I mean standing water. Water that can exist for a long period of time, persist. A stable star is a requirement for life. Why is that? Because when a star is hot and energetic, it tends to give off ultraviolet radiation, a lot of it. And when it gives off a lot of ultraviolet radiation, that's the best sterilizer of all. The Martian surface is dead because it doesn't have an atmosphere to protect it, and it's being bombarded with ultraviolet radiation from our sun. Our atmosphere funnels that ultraviolet radiation away from us and doesn't allow the radiation to get to the ground. This protects us. A similar case could exist on an exoplanet with liquid water, and life could form. On Earth, life formed in the oceans. And it was allowed to do so because the star was stable enough. It may not happen. There are stars that aren't stable at all, and we don't consider them for life-bearing, for their life-bearing properties. Now, there are various types of stars, and as you can see, we wonder whether they can all support life. The answer is, we don't think so, So I have to say we don't think so because I can't say no, because we don't know for sure. But this diagram is called the Hertzsprung-Russell diagram. I grew up on this diagram. On the upper left, you have O-type stars. You can see the label along the bottom. And those O-type stars are very hot, very energetic, and their solar winds are very powerful. So powerful, in fact, that any material that could build a solar system in that location is blown right out of that location, blown away from the star. On the other end of the scale are the M stars. These are the quiet, slow burners. When I say slow burners, by the way, I don't mean like a charcoal fire. I mean they burn hydrogen and turn it into helium. That's called the proton-proton reaction, the normal reaction for stars. That line you see from the upper left, it kind of snakes down, goes into the green and the yellow and then orange and red. That line is called the main sequence. That's where a normal star, like our sun, would sit. And on this scale, on the left side, you see luminosity. The one that you see, this one right here, indicates the luminosity for our star, and it puts us right about here in the G range. We're a G2 star. They go from G0 to G9 and so forth for the other spectral types. So the question we ask is, what stars can support life? Well, we discover that there's a consensus among most people studying these properties of stars that an A-class star and above have properties, solar winds, radiation potentials that best support planetary formation, never mind life. So O stars and B stars, in other words, early on in this scale, are too hot in our thinking now and too energetic to support planet formation. And if that's the case, then we won't have a planet around a B-type star. Yeah, we always hear about Pleiadians, beings that come from the Pleiades. The Pleiades are all B-type stars. So there's a contradiction there. Somebody's wrong. And it might be science, or it might be the people that think they see Pleiadians. I don't know. But only time will tell. But this is the basic way that we classify stars. O through M, hottest to coolest, brightest to dimmest. Here's an interesting fact for you. M-type stars are the most plentiful star in the entire universe. There's more stars that are M-type stars in our galaxy than other types entirely. And you can't see a single one with your eye. That's how faint they are. They're much fainter. That doesn't mean that if you look at them from up close, you won't see them. You'd see them. They burn and they look as bright as our sun, relatively. But they're small. And so from a distance, they're easily invisible. So our universe is a strange place. But we have to ask, how do we find planets that are around stars? For those A through M type stars, how would we find the planets? Well, here's a way. We'd use the Kepler Space Telescope. You've heard of the Kepler, right? Okay. The Kepler Space Telescope was launched in March of 2009, and it was holding station in space, looking at a small region of space. That small region of space was the size of your fist at arm's length in the sky. And the sensor on the Kepler Space Telescope, this is it, was curved. That curve, I just have to explain. When you have a lens system, the light coming through the lens system doesn't all focus on a flat plane. It wants to focus on a curved plane. So, and that's called Petzval field curvature. The Kepler Space Telescope sensor is designed to be curved so that the maximum amount of focused light can hit it. So the Petzval field curvature problem has been resolved for this. Again, I'm sorry I'm coughing. I actually have a paralyzed vocal cord. So that explains my voice, the need for the water, and the need for, and the hoarseness of my voice. So the telescope, here's a basic diagram of the telescope, because I have to explain what happened to it. It no longer works. You see all these different array of equipment on the telescope, But on the right-hand side, you see reaction wheels. Now, reaction wheels look like this. The reaction wheels are those black discs that you see, two on the left, two on the right. And actually, here's a close-up. Now, I took this picture in Glendale, Arizona, because I worked on a satellite that I thought was a spy satellite, because there was more classified gear on it than I'd ever seen. And they told me, you can't, produce a physical model, which I was making a model of it, that shows that gear. So I took all these pictures, and they said, okay, don't show that, don't show that, don't show that. Okay. Then I get a call from the CEO of the satellite company a couple months later saying, hey, Mark, you want to see who you're working for? And I go, yeah. I expected to see admirals and the Joint Chiefs and all that. He showed me a picture of Sergey Brin and Larry Page. It's the Google Earth satellite. So Google's in bed with the Defense Department. Not that you didn't know that. However, when we look at the Google Earth satellite, every aspect of that production of the satellite is controlled as these reaction wheels were controlled. Now, what does a reaction wheel do? It's a weighted plate that spins. That's all it does. There's 4 of them at angles, at angles to each other on both sides of the satellite. By changing the RPM of one of the wheels, you induce torque on the whole structure, moving it. This is how it controls where it's pointing and how it moves around. In the old days, do you remember the spacecraft had retro rockets? They'd fire, and the thing would move. Very dramatic. This isn't very dramatic. They just change the RPM of a wheel, and you get, and it moves a very slight amount. The benefit, it's highly accurate. However, if dust or something gets in there, the long-term effect could be devastating. That's what happened to the Kepler. It had 4 reaction wheels. It could operate on 3, and it lost 2. So this picture here is showing you the special garb being worn, okay? And yes, that's me wearing the garb. I don't know why, that isn't optional. And every day when I went into the high bay, it was called, where I was taking pictures of the satellite, I had to take this black braid you see along my shoulder and clip it to metal rails. And that would wick away the static charge on my body. And that you did if you came within 3 feet of the satellite. Because they determined that if you're closer than 3 feet to the sensitive electronics, you could fry them. So satellites are fragile, yet they're the most advanced thing we have for looking at stars and planets. So this points out the frailty of our systems. We lost 2 wheels on the Kepler, and that shut the program down. The Kepler worked by doing transit studies. Whenever a planet could be seen to pass between us and its star, called a transit, we'd see an imperceptible dip in the light coming to us from the star, illustrated by this diagram. And that, if you calculated out what that meant, you could say, well, that shows us that there's a planet around the star. And you get various characteristics of the potential planet. I call it potential because you don't know for sure. So Kepler worked by looking for transits. And as I said earlier, it looked at a fist-size location in the sky, which you see in the lower left of this diagram, up in the constellation of Cygnus in the summer sky. And it looked for those planets, and it found 2,000 big ones, and just a few smaller ones. But the statistical analysis indicated to us that it found nearly 2,000 exoplanets, yet there were thousands more. And that's where we're going. We're going to be going to look for other planets using other means. There's currently other satellites that are looking for them. And there's other methods used to find exoplanets. And one of those methods is radial velocity. If they see a transit with the Kepler Space Telescope, it's like, oh, we got a potential candidate. Okay, let's confirm it with radial velocity. What's that? Radial velocity is a case where you have a star and a planet that's orbiting the star is going to tug on the star a little bit and move it. You see that wobble? It's moving in a circular motion. As the planet goes around it, they're going to have a mutual rotation around each other. Now the planet, I'm exaggerating it, because that barycenter, or the common rotation point, will be inside the star for a star that has maybe one planet. But that wobble is detectable. It's detectable because as the star is coming toward us, the light of the star is slightly shifted toward the blue end of the spectrum, Doppler shift. And as it goes around the other side and starts going away from us, the light from the star will be red shifted, slightly away from us. So this is used as confirmation for a planetary candidate. And it's an awesome way to confirm planets. Now, this photo, which comes to us from the Gemini Observatory in Mauna Kea in Hawaii, is the first image of an entire solar system taken with light, regular light. It's an infrared image, and that black disk is called an occulting disk. And I've used those before. We put them in front of stars to block the glare and brightness of the star so you can see whatever's faintly around it. Here, you see on the lower right, just a little bit in the lower part of the screen, you see one of those planets, and you see two more above. The one on the bottom, which is closest to the occulting disk, is the distance away from its star that Neptune is away from our sun. So those two planets on the outside are even farther away. You see? So solar systems don't have to look like ours. Another method is called astrometry. Big word, but it just means checking for the motion of the star. It's related to radial velocity in a way, but astrometry will plot the wobble of a star over time. And the nature of that wobble will show whether it's being affected by one thing or two or three things. And if it's being affected by more than 3 or 4 or whatever, you've probably found the solar system. This is the oldest method that's been used for tracking and finding other planetary systems. It also has the most error. This is ours. This is our astrometric view of our sun. As all the planets go around the sun is moved and pulled in various directions by all the planets. That's the path that's been calculated. You probably can't read those, but those are little numbers that go all the way back to, the early, late 1800s, all the way through 1900s and 40s and 50s and 80s. So it's a slow process, and finding a planet takes a long time. You can't just go and say, there's a planet, let's go find it. You have to go back and get repeat data to see whether there was something there or not. Another method to find exoplanets, and this is cool because it's relatively recent, is called, as you can see, gravitational microlensing. If you have a distant star, and you have a star in the foreground that you think might have a planet around it, you don't examine that star, you look at the distant star and examine its light. We can see perturbations to the light coming from that other star that tell us that the gravity of something around this closer star is warping the light from that farther star. It's a happenstance event. It just happens that there's a star right beyond, far beyond it. There's a good likelihood that can occur, but, all of these methods require circumstances that are special. So we don't know whether these circumstances are all there are, or if there's other methods that we might be able to use further down the line. What we do know is that we track these things. We list them. This is the Open Exoplanet Catalog, at least the first screen. It's online, it's free, you can go look at it, and you should. You should become aware, and I would hope you would, of all the many exoplanets that we've found. And you can see that the planets around other stars are varied, unbelievable variants. You know, there's small ones, there's large ones, but the problem is we can't find the small ones very well. The small ones are very difficult to find. So on the computer, you can go to the Open Exoplanet Catalog, Mac or PC. On your iPhone, you can get the Exoplanet app and see the latest and greatest, and you'll get an alert. I found new exoplanets. And go see them. And when you click on one of those planets, it shows you its orbit, it shows you the habitable zone, it shows you what star, what type of star. And then most important for me, it points you to the astrophysical data links that you can go read and read about the papers about the discovery of the object. So our conclusions based on our statistical analysis are that there are, as you see, 40 billion Earth-sized planets in their habitable zones just in our galaxy. Our galaxy is 400 billion stars, approximately. I didn't count them all. But 40 billion planets is a huge number. You can't, in your mind, picture 1,000 anythings, never mind 1,000,000 or 40 billion. So these are just statistics. They're not proof, but they do stand a chance to show us that not only are we not alone, but we have armament against the media that would call us nutcases. Okay? As a media person, you would say, oh, yeah, those UFO nuts. Yeah, here, let me get them a tinfoil hat. You know, and you might even put it on for them, just to be funny. But if you said to them, well, actually, I don't accept your tinfoil hat because statistically, life is almost guaranteed. We see life everywhere, or not life, but the building blocks of life in our solar system, almost everywhere we look. Deep under Europa, there's hydrocarbons. Enceladus spews hydrocarbons. Enceladus is the moon of Saturn. Europa is the moon of Jupiter. Titan, cold as it is a relative snapshot of the early Earth and its primordial conditions. So it has methane and ethane lakes. So this carbon-based hydrocarbon existence is something that we find everywhere we look. So in my view, it's a populated universe. So the question is, and we'll shift gears a little bit here, in that case, where we think that it's a populated universe, what if they're here? How do we find them? You know, the elusive smoking gun. One way is to use a system we're developing called UFOTOG 2. And I'm going to show you what UFOTOG 2 looks like right here. Oh. I thought I was getting divine approval. It was looking pretty good. UFOTOG 2, as you've read already, is a scientific way to capture data that a human being just can't do because they'd have to be there 24/7. And the unit is powered by solar panels, which we've already redesigned. These aren't, going to work. And this is a mock-up. It's a non-functional mock-up, one-to-one scale of the system. It uses multiple cameras to scan the sky. And it can alert us. That red ball sends an alert to GPS satellites, which comes down to our smartphones in our pockets. All right? That already works. That works. And we can send, and basically we're piggybacking on these GPS satellites to get information about a sighting. Now, the point of this is a unit that's going to have and it'll give an answer to the fact that we always get bad data in UFO cases. There's a lack of good quality data. And the worst part is there's a lack of funded scientific research, and the data is bad quality. I mentioned before, cell phone video, look at my UFO, and you're just like, oh, I see it, but I can't tell what it is. you know. And then hoaxers use the latest CG technology. I admit, I've had to create very highly realistic UFO imagery for television programs. You know, I don't like doing it, and it's usually, actually, so far, I haven't had to compromise my beliefs. It's it's used to show what technology can do, not to try and fool people. And then we have to deal with a media that pigeonholes us, as you know. So we have our work cut out for us. But to challenge that lack of good data, there was a project called UFOTOG that was started. This is UFOTOG 2, different. UFOTOG was started by legendary pioneer and filmmaker Douglas Trumbull. Doug's an Academy Award-winning guy. He did Close Encounters of the Third Kind. He did Blade Runner. He did, well, tons of movies. And I met him 5 years ago when I found out he was a UFO hunter. I wrote him an email. And he said, hey, great, come on up. I can probably use your help, too. I'm going to go meet my childhood idol in special effects. I walked in, hi, Mr. Trumbull. And he immediately set me at ease by saying, that's right, I am a god. He was kidding, but he meant that he did say it. And I laughed, it set me at ease, and we've become good friends to this day, and we've worked together for 5 years. Now, I saw that he had created this concept called UFOTOG, and it was the predecessor to what you see here. The genesis of UFOTOG is interesting. It was a large Humvee, surplus, and it had a top that would open up, and on a big hydraulic lift, a theodolite would come up with telescope instruments on it. That entire thing weighed around 800 pounds. I'm talking about just the unit. And it could spin around in 1 second. It was very powerful. And it was used, if an object was seen in the sky, it would quickly turn and go right to that object. Now, Doug used his technology that he gleaned from doing motion control systems in movies and applied it to this. So there was a camera that was an all-sky camera, a domed camera. If it saw anything in the sky, it would send this little guy right over to it. And right away, 5 different instruments would capture the sighting. Sounds good, right? Because now we get not just fuzzy picture, we'd get an absolutely stock still picture, perfect, or a video, and we would get not just 1, but 5 different ways to see the same thing. The problem with UFOTOG, as I said to Doug, and he, of course, would tell you, is that that's 1 unit. It's one vehicle. If you're going to put a couple $100,000 into a vehicle, I think you want to get something that's going to have far-reaching capability. So I told him, I'll take the challenge on. Let me put together some people who can make this thing with us in a way that's a compact device. All right? Now, he had controllers, and the setup required a crew. But UFOTOG 2 is a remote deployment. This little guy will have visual cameras. That's what those black things are, here and all the way around, okay? There's 8 of them, and they cover the whole sky together. But you can zoom in much more when you can look through a camera with higher resolution. And the cameras are what are called 4K. They're twice the HD resolution. So you get even more ability to zoom in and have it stay clear. Now, a MUFON scientist that you may know named Chuck Maudlin is working with us on this project. He's been working with us for 3 years. And he's designed the camera. And the camera is able to go and show us the infrared and the visible spectrum. That's an achievement for such a small camera. Now, we also want to have UV sensors and UV cameras on here. That's not represented on our 1-to-1 scale mock-up. And a gamma ray detector, which is the silver thing you see there. Gamma rays, why gamma rays? Well, there are advanced propulsion techniques that the next lecturer, Bob Schroeder, is going to talk about. I normally go into them, but I removed that from my presentation so that Bob can go through it. His talk is an excellent approach to solving the UFO enigma, is going to cover the different ways that UFOs could travel in an interstellar way to get here not in thousands of years, but in minutes. That sounds like far science fiction. For us it is. But in our little sliver of existence in this universe, we already see astrophysical horizons where that kind of technology will be available to us. We just need energy. We need the ability to harness vast amounts of energy. What has the most energy in our solar system? The sun. So I'm not talking about a bunch of solar panels on the Earth. I'm talking about satellites in orbit around the sun that are capturing that energy, excuse me, and beaming it to the Earth via microwaves or whatever, and having it captured. So we already use the sun in a variety of ways. When I took off out of Las Vegas to come here, you could see the 3 bright hot spots on the ground, and that was a solar collector array setup. There were 3 of them. Big facilities, and some of those reflectors were always, they were capturing the sun and beaming the light to a central tower, focusing the light like a magnifying glass on ants, okay? And that would make it so hot that you can do stuff with that heat. That's one way of capturing energy. There's other ways, but, you know, that's not enough. We need to capture that energy, store it, and reutilize it. So, also on board would be a spectrometer. We would look at the spectrum of the object that's caught by these things, this thing, that thing. And the spectrum might show us lines. They're called either emission lines or absorption lines. These lines indicate the components that make up the source object. And that would help us determine whether this thing was earthly nature or not. We might see lines that we've never seen before. Don't know. So it's worth trying. Also, having a magnetic anomaly detector and an EMF detector is very important. I didn't list on here, but we also want to have a gravity detector. Why would we care? Because you can do it on your iPhone, so we want to do it on this, okay? Your iPhone has accelerometers, and those accelerometers basically are very susceptible. They detect movement and all that. But the acceleration due to gravity is constant, you know, for where you are right now. If you go up a tall mountain, it'll change ever so slightly and change all the way up the mountain. When I was on the plane, I used it and pulled it out. The acceleration due to gravity on Earth is minus 9.8 meters per second squared. On the plane, it was minus 9.6 meters per second squared. Higher in the atmosphere, lower the gravity. If I kept going up, well, the acceleration due to gravity would get down to microgravity, wouldn't it? Like the shuttle astronauts felt. So there's a number of instruments that we can put on this, and we have plans for all of them. And we're designing and building all of them ourselves. Why are we doing that? That'd be cheaper, that's why. Use off-the-shelf technology is great, and we're doing it with the SPOT guy, the orange thing you see there. The SPOT transmitter is going to send data up to GPS satellites and then down to us. But how are we going to lay these things out on the ground? This we call a platter. Very nice name. It's like dinner. A platter will have 4 to 5, maybe 6 different instruments on it, capable of capturing an event in the sky. We want to lay them out in an equilateral triangle, there it is, formation. Have 3 of these in an installation. Why? Well, because any 2 of them might see the same thing in the sky. And they'll see it and capture it with 5 to 6 instruments apiece. And now we can take that data and we can triangulate the altitude, the speed, and the location of that object exactly. A single platter would not be able to give you the distance to the object, nor its speed, nor its altitude. But you could just capture the qualities of the object, and that's it. So we're going to have 3 of these. Now, they're also going to talk to each other. That's what this antenna is for. Now, we will be talking using what are called XB radios. Now, they transmit data. That's all they are. They're just like a data transmission. But why would we have these units talk to each other? Are they going to rise up against us? Let's get them. The fact is that they have to talk to each other because they need to coordinate. If they see a sighting, they need to coordinate who's going to send the sighting to us. They need to coordinate who's going to look at the sky and say, okay, I'm the leader, you're the slave, you're going to follow my lead. And if we have 2 things that see the same sighting, 2 platters that see the same sighting, then we'll be able to have those units, without our intervention, do the triangulation for us and give us the altitudes and all that without our intervention at all. We would just get the result. I have an object 90 miles up traveling east to west, you know. Now, most of the time, objects like I just alluded to might be satellites. So, each of these platters is going to have a satellite database on board. That's not hard. That's easy, actually. And it's going to reference a satellite database and say, hey, I think you have, the ability to give me a satellite reading for this. Tell me what that is. And it might actually say, oh, that's just an old booster, you know. But it'll report it anyway. But it'll see a lot of satellites. They'll have a cellular system, basically a track phone on it. And that track phone will be used to communicate with us and take calls. Yeah, it can take calls. That's cool. And you could call it, and then you could tell it to give you information over the phone through a remote system, or in later phases, do what we call FTP, file transfer protocol. You log into the system and download the data. And I mentioned the GPS bounce already. When it sees an alert and it discounts it, everything is, it discounts all the normal things, then we'll say, okay, alert them. And it will alert us and show us the objects that it couldn't figure out. That's what it's all about. Now, I mentioned it uses the XB, and I mentioned that it will alert us via satellite. And I also mentioned that it uses the FTP, so we're covered there. Now, this is the system. I know you can't see this too well, but I'm going to show you real quick. These are the multispectral cameras. These guys right here are the multispectral cameras. They're going to be able to see the visible light into the infrared. Then we have the solar trickle charging. Since I've been at this symposium, we've already redesigned the solar panels. They're going to go on the post that this thing is going to be sitting on. Yeah, it's a work in progress. But this is going to be up in the air on a pedestal. And as I said during the field investigator training, that's to prevent the coyotes from peeing on it, you know. You think I'm kidding, you know? The last thing we want to see is, this, the coyote biting it. Hey, something shiny, bite it, Frank. Now we lose the camera. We don't want to do that. So then we have our spot transmitter here. I had it for the mock-up. I only had a round ball. I didn't have the actual spot transmitter, so it's a round ball, okay? And that's going to send the alerts that it filter through our system on board and say, oh, this is real, or possibly real, or it's anomalous. Send it. Now the cellular antenna is over here, and that cellular antenna is the thing I said that will communicate with us And you might say, well, what if you don't have cell service? That's a very real possibility. And that means we're going to have to rely on a GPS bounce, which will always get that alert. Then we're going to need someone to go out there and retrieve the data for us if we don't have any data connection to the unit. Luckily, we have fairly good cell coverage in the US, but we might actually have to have someone go out there. And that's why I'm showing this to a MUFON symposium, because last year Doug and I did a presentation for the board illustrating what we're doing and asking for MUFON's help, not monetarily. We're going to find the investors, but for the boots on the ground. So for those of you that are in MUFON, let your wheels get turning, because we would like to see MUFON manage all of our units, and we're going to turn the project over to them. The data is going to be managed by MUFON and us. The results are going to be released by MUFON and us. No one person is going to do anything without the other involved. This is, well, it's revolutionary in a sense. Now, just for the record, this is the gamma ray detector here. That already works. We had, not this one, but we have a working gamma ray detector. I'm not going to put a real gamma ray detector on here and cart it around the country. So, the concept of a leveling leg, that would be used on the pedestal to level it. Batteries are inside here. The block of blue that's kind of invisible under there, you can see it there. That would be the big battery. And MUFON's role, as I told you, is going to be to manage these things on the ground and to manage the systems, especially for phase one. Because during phase one, it's going to be a system that's under trial. But as it matures, we're going to have a better idea of where we want to go technically with these things, how to acquire the data quicker. We might be able to figure out how to do a satellite burst thing and send both the photos and the sighting to us via satellite. That's actually our ultimate goal. Another way to go, which someone in the field investigator training had mentioned to us, was something we thought about, but we had initially discounted. And that was to go with CubeSats, satellites, do it from above, launch satellites, and actually have something in the sky that's watching for these as well. We thought about that, and we discounted it because we want to do this. Echo, echo, echo. So anyway, we discounted that only because we didn't want to go down that path because it's too much. I already designed a seagoing version of this, and it wouldn't look down, it wouldn't look up, it would look down for USOs. Those of you who have heard me tell the story before, I witnessed a USO when I was on a nuclear submarine, not as a sailor, as a guest. And I mentioned before that to those that know, it was the most fun I had getting seasick. I sat in the sonar room to try and recover my stomach. And the sonar guy saw something anomalous, and the executive officer, after determining it was moving several hundred knots, said, log it and dog it. Log it and then hide it. All right, so we know our government is tracking these underwater objects as well. So I thought, well, we needed an underwater UFOTOG system. By the way, UFOTOG stands for UFO and Photography. I was remiss in not telling you that. And so the system in the water would be a shallow diver. It would hang from the surface on a buoy that's a communication system. And as it rode up and down on the wave column, it would ride up its tether, and then its own weight would pull it back down. And that would be charging it. It's a wave-charged system. So that works. That part works. But we had to set aside the ocean-going one because it's just too much to do. in one shot. So we're going to do the land-based units first. And the scientific charter of MUFON is the investigation of UFOs for the benefit of humanity. By God, that's what we're going to do. So I want to thank you for your diligence and putting up with my voice. If you have any questions, there is a mic here. You can come up and ask questions. So thank you very much. Apparently not. There it is.
So what a fabulous presentation. And,
Thank you.
We're just so thrilled to have you here. It's wonderful. That was
Thank you.
fabulous. My question is, how do you protect the UFOTOG? Does it have a glass dome over it or something like that? How do you protect it from weather? And then if it has a dome, like if it's snowing, right? There's weather issues, right? Or birds,
Yep.
depositing
Coyotes.
material on them and things like that. So
Yeah,
that
right.
was my question.
That's a good question. Thank you. Well, weather protection has been an issue for us, and we want to use hydrophobic materials that will repel water, say, or whatever. But we also have some ideas, and I even got a great idea from someone here at the symposium, at the FI training. He said, well, why not just have a system that closes as soon as it rains? I mean, it's simple. And the fact is, when it's raining, we're not going to get as reliable data anyway, because rain is moving objects through the sky. And we might alert on that falsely. So maybe it'd be a good idea to shut a dome over it. And then when it stops sensing water, open it up again. So we have to address the weather consideration. It could be a simple little servo-controlled system. It's very easy. Water sensors are a dime a dozen.
Is it possible that you would be able to interface with some other technologies that are already out there? I'm thinking of cell towers and radio towers that are very, very high, and could you utilize those, or would there be interference problems?
There will be interference problems, and they give off radiation that we're going to be looking for, and we'll be getting false positives all the time. But if we set up an object in such a place, we could set a baseline. This is the radiation we get here at this tower. Anything that falls outside of that range is interesting to us. So yeah, we could do something like that as long as we don't, fry the system by putting it too close to the transmitter on a cell tower.
And then my only last question is security. Like, have you started to consider those things?
Absolutely.
Because people are going to, is the government going to come and take these things down, or are other anti-ufology groups going to come and try to shoot at them and destroy the technology?
We're not telling the government where we're
they
putting
are.
them.
Thank
And to answer the question in a real way, we plan on mounting these on poles, maybe 8 to 9 feet above the ground. And there are, I was in going through the Nevada desert, you could see every now and then there's a pole sticking up. It's not vandalized. People leave it alone. They just say, oh, we got a thing up there, and then just move on. We're banking on that too, the anonymity. It's sort of unobtrusive, and they would have to do work to get it down. And most people don't want to do work to get it down. If it's on the ground, they can kick it, they'll kick it. That's easy. If it's in the air, right, as you said, nobody would see it on top of a water tower. But, you don't have enough water towers. You have a water tower, and, an equilateral triangle. That's a strange-looking water tower setup. But yeah, there's possibilities. Right.
Do you already have an idea about the location, or are you looking for a location?
Thank you, Thomas. That was a good question. We've considered location, as real estate agents like to say, right? Location. And we are in Southern California right now. I would like to, if we were doing the ocean-going ones, I would like to deploy them in the Santa Catalina Channel and let them drift along in the channel, pick them up, reinsert them into the channel if they move out of the channel. On land, we're going to do all of our tests in Arizona, in Wickenburg, Arizona, as a matter of fact. Why that place? Because that's where the lead scientist lives, who can access the system every single minute of the day and get the, make sure it's working right. Then after that, these are deployables. We can take these anywhere. We can send these to you in Arizona or you wherever you are. Where are you? Oregon?
Oregon.
Yeah, we can send them to you in Oregon and say, okay, I hear you got something going on. Go deploy these. And you'll say, yeah, but I can't do 3. I only have room for 1. We'll send you 1. And that's the kind of thing that would get you some data, but it would be data of 5 instruments for something that's in the sky. Now, I didn't mention this before, but it's important to understand. UFOs don't have to be visible. If they appear in the infrared only, you're not going to see them. If they appear in the UV, ultraviolet, you're not going to see them. If they're using methods of transportation that live within the realm of string theory, you're not going to see them at all, possibly, but you will see what they leave behind. I call those the skid marks. You'll see skid marks left over where the UFOs are transitioning into our dimensional space. We have 3 dimensions, X, Y, and Z, all moving through time. If we live within that dimensional space, then light speed is 186,000 miles per second. It's inviolable. We can't go faster than that in that reference frame. But if we can get out of that reference frame and live outside the normal universe, as Bob Schroeder will talk about next, then you'll be able to utilize a method of propulsion that allows you to punch out of our universe and punch in anywhere else. But when it does that, there's consequences seen in our universe. Gamma rays, okay, Hawking radiation, as you'll hear about with Bob, and more effects that could be seen visually. Every single reported UFO, the shimmering thing, it winked out, it vanished, and it moved in the sky and did some weird things, and it was there and it was there. All of those are explainable using this punch-in, punch-out theory. And that's what you'll hear about next with Bob. So, as far as location goes, we're going to send these wherever people are reporting a flap or hotspot. But we're going to set up a base number of instruments, probably in the Arizona area, all right, and set them up all the way out in the desert, in the Sonoran Desert, on poles, and it'll help us greatly. All right?
Thank you.
Thanks, Thomas. Der Spiegel. Lee Spiegel from the Huffington Post, everybody.
You mentioned many UFOs are invisible. And I don't know if I've ever asked you this before, but a couple of years ago, my brother was driving his 2 sons on an old road in New Hampshire, and they thought they saw some strange things, lights in the sky.
Yeah.
And so they pulled off the side of the road and got out to take a look at it, and one of the kids said, "Oh, Dad, it's probably a UFO." And it turns out after a minute or two, Jim discovered, well, no, it's probably just a plane. It's taking a different flight path, out of an airport. And they got back into the car, and my nephew Zachary said, "Daddy, why do UFOs need lights?" And well, Jim said, "Well, I don't really know the answer to that, but you should call Uncle Lee in New York and ask him, because he probably knows." But this is a thing that comes up all the time. I hear this question a lot more. If some UFOs are technologically advanced craft from somewhere, you'd think that with all that technology, they wouldn't need lights to help avoid each other the way we need lights. And I've heard some people say, well, maybe they're doing it so they can be seen.
We have nav lights on our systems so that we can be seen, okay, and see each other in the sky. A UFO might be illuminated by a consequence of its method of propulsion. So it may not be able to help being seen because of the nature of the propulsion. Lee and I work on UFO stories. He always asks me to, write in and be the fall guy. Okay, and I give him my stuff, and then I get all these nasty comments, and he's laughing.
And I get all the feedback from people saying, why do you always use this guy to analyze UFOs?
Yeah, I know. Sorry, science hurts, doesn't it? So that's what I was saying. The method of propulsion, whether it's buried inside string theory or the Alcubierre drive technology, which I didn't even get to. I took it out of my presentation because Bob's going to discuss things like that. Those types of propulsion technologies can cause an object to glow. You can actually generate glow in the lab, using these, using offshoots of these accelerated technologies. So getting a fluorescence of an object could be the natural byproduct of that.
Because you created an unbelievable UFO early drone about 4 years ago for National Geographic, and this thing was like rimmed with lights so that everybody in the town could see it.
Right, and even then I said there's no guarantee that UFOs ever even need lights. We've said that before.
Yeah.
But the fact that we did that is because that's what people expect. And we were doing a study to show why how a lit UFO object would be perceived by individuals when it was just sprung on them. So we launched this thing at a shopping center, and it was February, it was cold, and there was a light snow falling. So you saw this lit up disk of light in the sky and a sphere of blue light around it. That was the illuminated snow. We didn't count on that, but we were looking at it going, that's beautiful, wow.
Will UFOTOG see and record and register lit UFOs different from those that aren't lit?
Well, yeah, I mean, the visible light spectrum is what we know of in the nanometer range. And if we're looking for visible light objects, if there's a UFO that comes through and it's just like a white trail of light, then it does this, okay? We're going to capture that motion. However, if we don't see it, if it's in the infrared only, or if it's not even really there, if it's interdimensional, I know that sounds weird, but science is catching up to this, mind you, okay? And it slides over the sky and then drops. We might not see this path, but we might see a gamma ray emitted right here. Now we would say, what was that? What caused that gamma ray? And then we would consult all the other instruments and say, was there any kind of a spike in the infrared? Did we see any magnetometer changes? Did the magnetic field change? What happened to the local gravity? Okay, what about the spectra? Did we see anything on the spectral analysis? So it will see things differently, yes. But a lit object will also include all the other data that we're talking about. And a dark object will include all the data that we can see dark, magnetic field, gravity changes, EMF changes, and of course gamma rays and so forth.
Thank you, Mr. D'Antonio. I enjoyed your talk.
Thank you, Mr. Spiegel.
Thank you.
So I'm sneaking in to ask the second question because there's no one else waiting. And
Well, you asked
this
5 questions before, and this will be the 6th.
they say curiosity killed
Yeah,
the
go
cat,
ahead.
right? The trick, of course, with these is to have them in a locale triangulated when there's a UFO sighting.
Yes.
And that's the big if. How can you have a sighting? Well, I remember reading and studying Wilhelm Reich's work, and we've talked about this privately, but I'm going to put you on the spot with this question
I don't care.
publicly. When Wilhelm Reich created the cloudbusters and he started to experiment with them, especially when he brought them out to Arizona, he realized that UFOs started to show up. So, could you combine these technologies? Of course, it could be some danger involved a little bit, and of course, we know that the cloudbusters are illegal, so we'd have to figure out a way to do that. But if you had set up something, even a small one, maybe over time it would create the atmospheric changes. But then, of course, the cloudbuster brings in rain, so that's kind of counterintuitive to what you're trying to do, because you'd have to close them when it rained. But are you getting my drift? Is there a way to set up something that could stimulate UFO activity and then photograph it?
I am getting your drift. You're asking if I can do illegal activities in order to bring UFOs in a public forum. Well, the answer is that we plan on producing a high volume of these. Now, I didn't allude to costs. I didn't even mention costs yet. This is a work in progress. We're still working on creating the first units. But what you need to understand is we're making those ourselves. Not, assembly line, okay, pump out the cameras. We're going to, pot this to a circuit board, make this a camera, and then produce the cameras. And it'll be really cheap for us to produce the cameras. We do that, now that brings the cost down because we don't involve a third party. It's just us doing this. And then the transponder that sends to the GPS, that's a standard item right off the shelf. We're just going to modify it a little bit. And that's us. That's on us. Okay? All right.
Yeah. I had an experience here in May of this year where there was a huge triangular UFO in daylight. It was about 7:30 in the evening. It was in Las Vegas, in Henderson, Nevada. But what the question is that I saw this thing, and we saw it for about a minute and a half, and then it just disappears like that. But that particular night, and then that evening, all night long, every dog in the neighborhood was going nuts. Does that, did that thing actually disappear? Is there a way of determining whether does it cloak itself? And if it does, can you still see it with your equipment?
Well, first of all, we're not going to put a dog on every unit, but that's a good idea.
All right. Okay.
No. I'm sorry, I couldn't resist that. Okay? He's asking a great question. I've been in Henderson. One thing I'll tell you is this. You mentioned this thing in the sky. There's discrete events occurring there. Okay? You see it, it's visible, we'll catch it. It winks out. That's a transition to something else. That might give off other radiation that we'll detect. These are the smoking guns we're looking for. So now there's those of you in the audience saying, but it's just a little thing. How's it going to see enough of the sky? If there's enough of them out there, okay, a mile apart, that's all they need to be, is a mile apart. 10 units covers more than 10 miles because they have 10 miles plus their horizons, So we'll be able to capture all the events you see. And then for your event, we might capture a visible light event and a radiation event. But in visible light, we'll also see it vanish, And if there's an infrared signature when it vanishes, we'll see that too. And if it goes into higher energies and goes into ultraviolet, we'll see that too. So you see, we're bringing to bear sensors, never before done, to try and bring out the subtleties of the UFO event.
Okay, thank you.
Thank you, Thomas.
Yeah.
My name is Leon Freeman, and I have a question I hope you can answer. I'm from Memphis, Tennessee, and I guess about 8 years ago I saw a UFO, so I know they exist. After that, I started going to UFO conferences just to find out what it was. And I have a real estate business. I guess about 5 years ago, a tenant by the name of Dexter Shegog, I got a picture of he and his mother. He moved in, and after he was there about 3 months, he asked me would I do him a favor. I said, I don't loan money. He said, no. He said, I want to know how much would you charge me to take him to Polk, Mississippi for a family barbecue. I said, if you all let me eat free, I'll take you for nothing. Never mentioned UFO at all. Drove down to Polk, it's about 3 hours outside of Memphis, and I do a lot of travel. I've been to 120 countries around the world. I took some of the pictures that places I traveled. So when we got down, I met his mother and his grandmother, and they were excited. Still didn't mention UFO. Came back to Memphis, about 4 months later he moved. And I went to a UFO conference out in Denver, Colorado. And when I came back to Memphis, I went to a new restaurant called the Covered Restaurant on Union Avenue, and he worked there. And I said, when have you been back to Polk? He said, I'm going this weekend. They're having a birthday party for everybody whose birthday's in this month. So I said, well, I'd love to go. And I took one of those DVDs from the UFO conference that I had. Still didn't mention UFO, went down there. And his first thing, his mother asked me, where have you been lately? I said, let me show you a brand new DVD I got at the conference. She put it in 3 DVD players that would not work. I said, that's kind of strange. I said, this is about UFOs. And now, Polk, Mississippi is a country town. It's so isolated, they don't even have a traffic light. You might go 2 or 3 hours before you see another person. There's just nothing down there but just country. And I asked him, I said, well, I said, about UFO, have you ever seen a UFO? And his mother said, she said, I don't know. She said, but I was coming home from work about 2 weeks ago, and these two bright lights was following me, and she said that I started to speed up, but they could get me if they wanted to, which was kind of strange.
Well, what you're mentioning, and I'm sorry to move you on here, but what you're mentioning is two lights in the sky following. I've heard that before from people who are talking about lights that appear to be following them. A very distant object on the horizon will look like it's following you because it's far away. And so it'll always keep pace with you as you're driving. I don't know if that's what she saw, but it's possible.
But,
now, I'll continue talking to you
okay.
offline. If you want to wait, I'll talk to you. Okay, but we have to finish up. I've got a screen here that's telling me to stop or I'm going to choke you.
Well, let me show it. Okay, well, look, because this is the hardest thing. The mother told me in the process of talking, her son, when he was a little boy, he would say, Mama, these people come and get me and take me out the window, and they don't open the window. And to make a long story short, he and I were going to the little thing, and I asked him, had he ever seen a UFO? He said, I don't know. He said, but I remember like it was yesterday. He said, I was 18 years old. He was on a little hill, listened to the radio. It was dust dark. He said, your light was shining down. He looked up to see what it was. That's the last thing he remembered. What he remembered next, he was in the bed naked the next morning with his shoes on. And his grandmother did not let him in the house. And he doesn't know what happened to him.
Well, I'll just tell you real quick. My son was 9 years old when he started sleeping in my bed, and I couldn't get him to stop. When I finally got him to tell me why he was sleeping in my bed for 3 months, he started to cry. And he said, I'm afraid the aliens are going to come through my window and take me again.
So do you think this fellow was really abducted? I mean, that's what, it
That's
baffles
possible.
me.
There's abduction places, there's abduction groups, I think, that are going to be here. You can talk to people as well. But we can continue talking offline.
Okay.
Mark, thanks so much for your talk.
And thank you, Leon. Thank you.
And I don't want to put you on the spot, but I do want to ask
I'm
this
on the
question.
spot.
So I don't expect an answer, but
Right.
your idea is so fantastic that perhaps I'm wondering if you might publish the designs and allow us to build them ourselves.
Well, that's actually a very good question. The UFOTOG 2 unit is going to have a design specification that we're going to make public, all right, because we want to see more people do this. We're not looking to take this and make tons of money. We're looking for answers. We want the answer,
Great.
okay? All right. Thank you. Thanks, Don.